Right now, there is an uproar in social media about some new discoveries of Webb telescope. Many people are claiming that the Webb telescope's new discoveries are proving our Big Bang model wrong. Is it true? Not really, due to misconceptions about the Big Bang theory among the general public making it true. To understand this, we have to understand the Big Bang theory very well. So let's start. We have tried to unravel the mysteries of the universe with our imagination from the very beginning. And we made theories to understand every event happening in the universe so that we can understand the early universe much better. Surprisingly, to some extent, we were able to understand these things. But the beginning of the universe is still a complicated thing that our theories have not yet understood. To understand all these secrets, we made some scientific models. It's like a framework of ideas that helps to understand how known scientific facts could fit into an overall time sequence. There were several scientific models, but in the end, only one became widely accepted. And we named it the Big Bang Theory. But this cosmological model has created misconceptions in everyone's mind. Before understanding it, let us see how this model actually came into existence. The Big Bang Theory developed from observations of the structure of the universe and from theoretical considerations. In 1912, an American astronomer named Vesto Slipher discovered that distant galaxies are redshifted. In addition to this, he observed something interesting there. He found that almost all the redshifted galaxies were receding from Earth. He did not grasp the cosmological implications of this fact. In 1924, Edwin Hubble estimated distances to these galaxies, whose redshifts had already been measured, mostly by Slipher. Hubble discovered a correlation between distance and recessional velocity. He observed that galaxies are moving from Earth at speeds proportional to their distance, known as Hubble's law. To explain this recessional velocity, in 1927, Georges Lemaitre, a Belgian physicist and Roman Catholic priest, independently derived Friedmann's equations from the Einstein field equations. Those equations suggested that the inferred recession of the galaxies was due to the expansion of the universe. He further suggested that the evident expansion of the universe, if projected back in time, meant that the further in the past, the smaller the universe was. Until, at some finite time in the past, all the mass of the universe was concentrated into a single point. During the 1930s, this cosmological model was competing with Fred Hoyle's steady-state model. Surprisingly, Hoyle was the first to name Lemaitre's theory as the Big Bang Theory. Eventually, the observational evidence began to favor the Big Bang Theory over the steady-state theory. The discovery and confirmation of the CMB, in 1964, secured the Big Bang as the best theory of the origin and evolution of the universe. There is still much debate about this theory, and new discoveries from Webb telescope are fueling this debate even more. All these misconceptions are mostly due to the name of this cosmological model, which even Einstein did not like. John C. Mather, senior astrophysicist and Nobel Prize winner, says, "The name Big Bang has been misleading scientists, philosophers, and the general public since Fred Hoyle said it on radio in 1949. This name conjures up the image of a giant firecracker, an ordinary explosion happening at a place at a time, a collection of materials suddenly beginning to expand into surrounding empty space. But this is so exactly opposite to what astronomers have observed that it is shocking we still use the name. If we ignore the name Big Bang, then this model states that everything in the observable universe is moving away from each other because the universe is expanding. This expansion is not as simple as we think. There is no center of this expansion. Wherever you stand in the universe, you would conclude that the universe appears to be receding from you, and you are the center. You may have heard pop science programs describing the Big Bang as happening everywhere. And this is what they mean. Expansion happened at every point in the universe, not at a particular point in the universe. As the distant galaxies appear to be receding from each other, with a speed roughly proportional to their distance, by dividing the distance by the speed, we can find out when this expansion started. With precise calculation, scientists found that this expansion began around 14 billion years ago. It was the time when the entire observable universe was compressed into a single point, known as gravitational singularity. It's not like a normal point in the universe. It was a very odd situation, where the spacing between every point in the universe is zero. With our current theories, this is beyond humanity's capability to explain. The Big Bang theory does not tell anything about this situation of the universe, but rather, it describes the emergence of the present universe from an ultra-dense and high-temperature initial state. So, did the Webb telescope really prove our model wrong with the new discoveries? Nope, JWST did not prove our model wrong. All new discoveries by Webb telescope are telling us to improve our galaxy evolution model. Because, within days after beginning observation, Webb telescope has spotted a candidate galaxy that appears to have been shining brightly when the universe was just 230 million years old, which is more luminous than astronomers had expected. Also, the Webb telescope saw 10,000 times more galaxies in the early universe than what our model had previously predicted. Another Webb survey found that disk galaxies formed earlier than we expected. If all these claims are true, then we have to resolve our current understanding of how the universe evolved. This does not prove that the Big Bang theory is wrong, but rather it suggested that our galaxy evolution model needs some improvements. Maybe these new discoveries show us the hidden forces that can help us improve our galaxy evolution model, and maybe we can get more information about dark matter and dark energy. It is not the first time something like this has happened with our Big Bang model. Previously, in the mid-1990s, observations from certain globular clusters appeared to indicate that they were about 15 billion years old, which conflicted with most then current estimates of the age of the universe. This issue was later resolved when new computer simulations, which include the effect of mass loss due to stellar wind, indicated a much younger age of globular clusters. Webb did not prove our model wrong. The Big Bang model is still the best model about the evolution of the universe. It does not say how energy, time, and space were caused, but rather explains how did the present universe come into existence. The actual universe appears to be infinite now, and if so, it has probably always been infinite. The universe is there when nothing exists. It has always existed, though perhaps not in its current form. Also, there is no sign of an edge of the universe, no place where we run out of either matter or space. This is what ancient Greeks recognized as infinite, unbounded, and without limits. There is plenty of mystery to go around, like how the initial state of the universe originated is still an open question. Stay tuned, there are some more Nobel Prizes to be earned.